just like its IPv4 counterpart, RIPng supports the concept of doing prefix filtering. So, I mean, again, we're CCIE candidates at this juncture, and we want to make certain that we know not only the basics of the protocol, how to exchange prefixes and updates, but let's be honest with each other. If we are tasked to do anything with any routing protocol, we're probably going to have to do something with regard to manipulating the default or basic behavior. So it's not going to be just enough for us to cover the initial precepts or the default operation of a protocol like RIPng, even though it's not going to be a hugely weighted topic in the context of the Routing and Switching version 5 exam. But I still want to make certain that we cover as much of the topics as humanly possible. So what we're going to do is again, we're going to go over to R1 and we're going to create a loopback. This loopback is going to be FC00, and what I'm going to do is I'm going to specify this as being 1:1:1:1:1, and I'm going to advertise this as a slash, excuse me, I'm going to advertise this one as a /64. So no different than what we did on our previous config. So let's cut over to R1, and we'll create this loopback, do show IP interface brief, E assigned, and we'll just make it loopback, let's say, .300. So interface LO 300. IPv6 address, and let's go ahead and give it a link local address of FC80::1, link local. Now that says it's an invalid FC, it's FE, sorry. FE80::1 link local, because FC isn't approved for use as a link local address. That's why we got that message. IPv6, I said we would use address 2001, so no, we'll use FC00::1:1:1/64. Now we want this particular prefix to be advertised into RIP Next Generation. We do that the same as we've been doing it all along. IPv6 RIPng enable. Now that protocol, that interface should appear on R22 if we're patient. Let's cut over to R22 and see if it appears on our data center. Show IP route, and I'm going to say FC00::1:1:1:/64, and let's see if it actually appears so as IPv6 route. And there it is. And according to this, we're going to load share to reach it via our connections to R3 and R2. So let's double check that. So if I want to trace route to IPv6 address FC00::1:1:1:1, we're going to see that I'm going to load share through R2 and through R3. That means I'm going to pass through Cat2, Cat1, all the way to my destination of R1. Now, R1 here. So, with that being said, we're learning the prefix and we're actually using load sharing. Now, what I want to do is I want to use another tool. The tool that we talked about in the confines of our studies for RIP version 2, one of the biggest tools for filtration was a distribute list. Get my head out of the way. Now, a distribute list, again, allows me to match on different criteria. So let's take a look at what that would look like at the command line. So what I'll do is on R22, I'm going to say IPv6 router RIPng, and what I want to do is I want to look at the distribute list command. Now the distribute list, notice now I only have one option. I have to use a prefix list. Now what I'm going to find is that I have to use a specific type of prefix list, a prefix list that's going to be called an IPv6 prefix dash list. All right, let's look at what that's going to be and how it's going to play out. So I have no other choice but to use this idea of a prefix list. So let's see what's involved in that process. So I'll just go ahead and clear this stuff. And I want to create a scenario. I love this idea of being able to demonstrate all of these technologies in learning scenarios. So here's the situation. On R22, I do not want to learn about this prefix, FC00:1:1, :1:1:1. I apologize. I don't want to learn about the prefix of FC00:1:1:1:/64. I don't want to learn about that at all. So what I'm going to do is I'm going to apply a distribute list, but I'm going to apply it to my process, not just to an interface. So let's see what's going on here. So I'm going to take it out of my routing table entirely. So that's the first scenario. So scenario 1, I do not want to learn. Not want to learn this prefix at all. So how do we do that? Well, first we need to match on that prefix. And we're going to do that using this idea of an IPv6 prefix list. Now, what I'm going to do is I'm going to say filter. And what do I want to do? I want to filter FC. Let's say we'll filter R1's LO 300. All right? So I need to deny that. So I'm going to say deny. Now the network that I want to deny is FC00:1:1:1:, specifically the /64. Now, obviously, I need to be able to permit all of the other traffic. So what I'm going to do is I'm going to modify this. I'm going to say IPv6 prefix -list filter _R1 _LO 300, and I'm going to use a permit, and the permit that I'm going to specify is to match everything. So it's going to be ::/0. Now ::/0 is going to match any range, but the other thing that I need to specify here is that I want to make certain that it's going to be any value that has a mask that's less than or equal to 128. I'll take myself off the equation here. So less than or equal to 128. So now what I've done is I've created the prefix list, the IPv6 prefix list, that I'm going to use to match the traffic of interest that I want to filter. So now let's take the next step. The next step is going to be to go into my routing process one more time. So it's going to be back to that IPv6 router RIPng, and I'm going to use distribute list, prefix list, and the value that I'm going to assign is going to be this idea of filter R1's loopback 300 interface. And what I'm going to do is I'm going to say in. So I'm going to filter it in. And I'm going to hit enter. Exit. Exit. Do or clear IPv6 route star. And let's see what's going to happen. All right, it's had time to kind of do its thing. So let's say show IPv6 route. And I want to see the route specifically for FC00:1:1:1:1, and I'm going to hit enter. And what I'm going to see here is it's still in my routing table. And again, this is going to be waiting for our system to converge. So let's take a look at this. Show IPv6 route RIP. Let's make sure I didn't match on the wrong value. So I'm looking for FC00 FC00:1, and I'm learning this prefix. Actually, this is the one that I'm wanting to learn right here. Still says I'm learning it from these values here, from R2 and R3 still. So again, we just simply need to wait and see what happens. Show IPv6 route RIP. Okay, show IPv6 route RIP Still learning it. So here's our network. So let's double check some stuff. Show IPv6 prefix list. Now let's see if I'm matching on the right thing here. So I'm FC00, FC00, :1, :1, :1, :1, 64. Should be being denied. So let's take a look at do or show run section IPv6 router. Let's see here. Did I get my values right? I copied it, so I would imagine it would work. Filter _R1 _ LO300. Distribute list in. So far, everything seems like the configuration is proper. So let's try the show again. So show IPv6 route. And now it's not in my routing table. Even though I cleared the IPv6 process, it still took a long time for it to be removed. So now if I wanted to be able to try to ping this, ping FC00 :1, :1, :1, 1, I'm not going to have reachability. And the reason I'm not going to have reachability is because it's not inside my routing table. I don't even have a default route that's going to allow me to be able to reach that particular prefix in a pinch. So again, what I did is I filtered it on the basis of the process. Now let's take a look at another component here. So config T, route, IPv6, router, RIPng, and let's say here, distribute list, prefix, we'll just throw in an arbitrary here, we'll just say bogus, in, and we also have the capability of changing this behavior. So let's take the actual distribute list that we configured. So let me just scroll up. And what I'm going to do is I'm going to say filter in, and I want to say I don't want to learn this if it's coming in a specific interface. So I'm going to say serial 2/0. So I don't want to learn this prefix from R2, because if we look at our topology, it's going to be serial 2/0 that goes to R2, and then it's going to be serial 2/1 that goes to R3. But the thing is I want to also illustrate the fact here, let's take a look at our running config. Do show run section IPv6 router. And what we're going to see here is both of these values are still in my routing table. So if I want this to actually work the way I want it to, I need to remove the one that is going to be the least specific. Because what's happening is we're filtering it basically twice, and we want to make certain that we do learn it via this serial 2.0, or I'm sorry, this serial 2.1 link. So I'm going to say no, and get rid of this config, exit, exit, clear IPv6 route star. And what I'm going to do is I'm going to go back to my trace route. Well, first let's see if the route appears in our routing table. Again, we just have to wait. Okay, now the route has appeared in our routing table. But let me illustrate something here. What I've been typing is clear IPv6 route. Now I have the capability of clearing all IPv6 routes, or I could configure it based on specific addresses, or I could do it on the basis of virtual routing and forwarding instances. I just wanted to illustrate that. But the main goal here is going to be to do a trace route now. So I want to trace route to IPv6 address FC00 :1 :1 1, and what we're going to find is we're no longer load sharing. So I used filtration for the purposes of being able to black hole all traffic associated with the loopback 300 on R1. I also used it in order to be able to manipulate which path I may want to take inside of my infrastructure. But bear in mind, if I lose the connection that I'm actually using, so if I lose the connection to R3, config T interface S21, and I shut that down, because I'm using a distribute list, this prefix is not going to reappear in my routing table. So now if I come up here, end, and I verify that I have reachability, I'm not going to be able to hit it. And I can wait all day long, and I'm never going to be able to hit it, because what's happening here is the distribute list is going to prevent me from placing that prefix into my routing table on the interface. So it's not like what we were doing when we were playing around with administrative distance manipulations and RIP version 2. Distribute list is going to be an all or nothing situation. We're using a distribute list by virtue of the fact that we're blocking it via a specific interface. Even if we lose a secondary interface, we're not going to be able to place that prefix inside of our routing table. Very important for us to understand that that's going to be the case as we do these deployments. And again, what I want to do is continue to look at aspects of RIPng. So I'll see you guys in the next video.